Okay, guys, so lesson 2.10, unit 2, lesson 10, final lesson of unit 10. So before we take that topic assessment, so make sure you understand each one of these. You've taken each one of the quizzes, you've done each one of the XLs, so you've gotten the best score possible, and you're ready to take that topic assessment. Okay, so here's what we're looking at: operations with numbers and scientific notation. Okay, it says, how does using scientific notation help when computing very large or very small numbers? I'm going to show you an example where we're going to go through and divide numbers in scientific notation, and then we're going to have another example where we're going to multiply those numbers. The nice thing is, if you remember how to multiply numbers with exponents or divide numbers with exponents, it's the same thing. Okay, guys? So in example 3, they talk about bacteria. They have bacteria in a stadium, and they go through and they tell you how much bacteria is in the stadium total, and then how much bacteria would be from each person in the stadium, okay? And you need to figure out how many spectators there are based on that. So the total bacteria is 22.6 times 10 to the 18th power. Obviously, if I did that out in standard form, that would be very, very long, okay? And then we have per spectator 1 times 10 to the 14th power. So what we're going to do is we're going to go through and we're going to divide these two, okay? Remember, every fraction, and this is the form they put it in example 3, is a division problem. So the first thing I'm going to do is I'm going to put this out as a division problem. So 2 6/10 times 10 to the 18th divided by 1 multiplied by 10 to the 14th. Okay, so what I'm going to do is I'm going to divide 2 1/6 divided by 1, okay, and then I'm going to do this multiplied by, okay, 10 to the 18th divided by 10 to the 14th. Now this one's pretty obvious, right? This is just 2 6/10. And then we're going to put multiplication because we're going to switch this. Now, when we do this, all we do is we subtract the exponents. Since I have 10 to the 18th, 10 to the 14th, in other words, it looks like this: 10 to the 18th minus the 14th. And so what we end up is with 10 to the 4th. Okay? So this is the amount of spectators that are in the stadium at this point. Okay? And so we can write this in standard form. So in other words, I do this. I do, oops, right, wrong number, right? 2 6/10. So remember my decimals here. So I'm going to go 1, 2, 3, 4. And I put this here, and then I put the comma here. That means we have 26,000 spectators. Okay, guys? So all we do is divide the whole numbers, subtract the exponents whenever we're dividing. So remember to put this in your notes. You can look back on it, even on the topic test, okay? And so that you can go through and have valid notes. Now I'm going to look at multiplying. Now this is one from your quiz, okay, guys? So this is quiz number 1, quiz question number 1. Now we do virtually the same thing here. We go through and we're going to multiply these, okay? And so what we're going to do is we're going to multiply the whole numbers, and then we're going to multiply the powers of 10, okay? So in other words, this becomes 9 6/10, and I'm going to put this in parentheses, multiplied by 6 7/10, okay? Then we're going to multiply that by, and I'm going to put this in the structure, it's actually 10 to the 3rd power, right? 10 to the 3rd power plus that 2nd power that's there. Okay, guys? Now, they're going to only ask you to go through and put this in scientific notation. We don't have to put this one in standard form. When I multiply these two, what I get is, well, let me do every step, okay? So it becomes 64 and 32/100 multiplied by 10 to the 5th power. The problem is this is not in proper scientific notation. Remember, to have it in proper scientific notation, you can only have one number in in front of the decimal. So in other words, I need to take this decimal and move it over here so that this becomes 6 and 432 thousandths times 10. Now, because I moved this decimal, I made it smaller, right? That means this needs to be larger because it's still representing this number. Since I only moved it one place, I add 1 to this, and this becomes to the 6th power. This is the correct answer. Okay, guys? So remember, whenever you move this, if you make the number larger, then the exponent is going to get smaller. If you make the number smaller, just like we did here, then the exponent gets larger, however many places you move it over. That's it for this lesson. If you have more questions, make sure you ask, just like I always say, and we will move forward on that. Okay, so good luck, guys. End of another unit.